Hello, good morning everyone. Welcome to today's lecture. Today, remember that now we are going to move to another component of the module, and we are going to be talking about NoSQL databases. Okay, we are going to be spending a couple of weeks talking about NoSQL databases, and in particular we are going to be talking about document-oriented database, Mongo database, and we are also going to be talking about graph databases. We are going to cover these two main models, if you like, of NoSQL databases. Okay, remember that NoSQL databases is not only one particular type of database. Okay, this is including different concepts of databases. And in particular, now we are going to be talking about graph databases, and in particular we are going to be talking about Neo4J, in my opinion, one of the most popular graph databases that we have available out there. Okay, but this is not the only graph database that we have. There are other graph databases that you can also have. Now, here we have to take into account that we are talking about NoSQL databases. So moving from one database to another one is not going to be as simple as moving from a SQL or relational database to another SQL relational database. In SQL, we have that concept of structured query language, which is going to be almost the same for all relational databases. In NoSQL databases, this is one of in my opinion, one of the disadvantages of NoSQL databases, that is not a standard. Okay, so if you want to move from one SQL database to another one, even if you are talking about in the same concept of the database, you will have to learn the language of that particular database. Now, the guys from Neo4J, they are working in kind of standard language, which is called Cypher. Okay, but the problem is that not everyone is using this one, but they propose a quite nice language, which is called the Cypher language, in order to have something similar to SQL, and that's another reason for using this particular database. Okay, so basically, before we continue, something important about graph databases. Okay, we have been using a graph for quite a long time. Okay, but probably we don't use it. In the past, we have not been using this concept of graphs as in graph databases, but we have been using graph in so many other contexts. And for more than 400 years, we have been using graph. Okay, the graph as a data structure. Okay, this is not something new. It's just that now we are using this in the context of NoSQL databases. Now, we have the concept of NoSQL database is quite new. Well, relatively new, it's a little bit more than 10 years old. And then the relational databases are a little bit older. Okay, it's like 40, 50 years old and quite popular. But the concept of graph, as a concept, we have been using that for way longer than relational databases and NoSQL databases. Okay, and what is a graph? Before we start working in a graph database, let's have a look at a quick introduction of a graph. Okay, because we need to understand the concept of a graph as a data structure in order to use it in a graph database. Okay, I'm quite sure that you are quite familiar with the graph as a concept in computer science, but still, let me just quickly cover this. Okay, in a graph, the idea of a graph is that we are going to be connecting entities or objects, okay, that are going to represent a connection or a relationship between two objects or entities. Okay, basically we are going to say that we have nodes or vertices. Okay, so this is one node in the graph, this is another node in the graph, and this is another node in the graph. And in this particular example, we are going to be saying that these nodes are going to represent individuals, and the connections, they represent some sort of relationship between these two individuals. Could be that they are friends, that they know each other, or that they appear in the same movie. Well, that depends on your particular context in the graph. Okay, and basically we are going to be saying that this is going to be the set of vertices or nodes in the graph, and this is going to be a set it's a mathematical operation that we can use. So we are going to use a set in order to represent the set of nodes. We have the first node, the second node, and the third node for this particular example. And now the edges or the connections, we are going to represent that as a pair, two elements, which are two nodes in my graph. Okay, so basically we are going to say, for example, that we have a connection between Luke and Leia, which is this one here. This is this pair representing the connection, and in this case we have direction. So basically the first one is going to indicate that it's going from the direction, the connection is going from Luke to Leia, and it's going from, and so basically this one is the second one, indicating that it's going from this node to this node, and the last one is indicating that we go from this node to this node. Okay, so basically this is how we can see a graph as a concept. Okay, before we go into creating a graph database and so on and so forth, we need to quickly recap the concepts of graph, which I assume that is quite, you are quite familiar with this at this point, or somehow familiar with this. Okay, so basically, as I said, this is just a mathematical representation of relationships between items. It could be entities, could be objects, or whatever we need to represent in the graph. And we're going to represent a graph as the set of nodes or vertices and the set of edges or connections that we have in my situation, in my problem. And we are going to have, again, these nodes are going to be a set, and we represent that using this in this way. And we are going to represent the connections or the edges also as a pair, okay, indicating the first node and the second node. Okay, and this is how we're going to represent the connections in the graph. In this case, we have the connection, we have a direction, and that's going to represent the starting point and the ending point of that relations. We are always going to have two elements, it's a pair always, these connections. And for example, let's have a look at this toy example, and we want to identify the number of the set of the nodes and the set of connections. Okay, so here we can start. For example, here we can have that this is a set, so we are going to start, for example, with A. We know that this node is in the graph, and then we have B, and then we have C, and then we have D. Okay, so this is a set, so you can write this in a different order, and it's going to represent exactly the same information. The order is not important. Okay, so that's whatever the important is the content, the information that we have inside the set. Now for the connections, okay, we are going to represent that as, for example, we can start with this connection here from A to B, and we can continue now with B to A, and we can continue with this one here from C to B, and we can go from C to D. Okay, so this is just how we can represent this graph using this set notation. Okay, so basically these two sets here are going to represent this visual representation of the graph. Okay, so this is not really complex, this is exactly what I mentioned before. Okay, so basically these are the set of the nodes that we have, A, B, C, and D, and again the order that we represent this, for example, here I was using starting A, B, B, D, and here we have C, B, so the order is not, the order is going to be, this is a set, and the order is not going to represent, is not relevant. Okay, so you can have that in every order, and it's going to represent exactly the same information. Now in this case it's CB, so basically we are representing this one here, and here the direction is important, and basically the first one indicating that the first one is starting in the first one, and then it goes to the second one. So from C to B, now from A to B, from B to A, and from C to D. Okay, so this is just the representation of the graph. We can have graph is a popular data structure that we can use in order to represent, to model situation is in social networks. Okay, so it's a very popular data structure that we use in order to describe or represent data in a social network, because we have, it's a perfect solution because we have the individuals, okay, and then we have a connection, for example, representing that they are friends. For example, if you are talking about Facebook, okay, we have a Facebook account which is representing an entity, an individual, and then they are connected if they have, there are multiple connections that we can have in a social network. One, it could be representing the friendship, okay, that we have friends, okay, and then we are going to have, for example, in this case, in this context, this particular individual is going to have, for example, 3 friends. Okay, assuming that this is going to represent a friendship relationship, but it could be representing some other things. So we can have here labels in order to represent other relationships. For example, thinking about it, we can represent a relationship if I'm liking a picture of, for example, I have a Facebook account and another person is going to have a Facebook account, and we probably are not friends, but we are connected because, for example, I'm liking a picture of the other person. So that could be another relationship, and you can think about so many different relationships, and that's what we want to represent in a graph databases. Okay, so basically it could be any kind of relationships for the nodes that we have, the entities, the objects, or anything that you want to represent with your graph. Now, something important that we can have in the graph is that if we compare, for example, this graph, if we look at that initially, it might look that the graph is different, that it's representing different data, but no, this is not the case. These two graphs are representing exactly the same data. It's just that the visual representation is going to be different. For example, we know that we have these two connections, and we have these two connections in here, Flexo vendor. Okay, so basically we have these two connections here, and Leia is going to have, this entity is going to have 3 connections, and so on and so forth. So basically what we want to say here is that we can represent the visual representation of the graph. We can represent that in so many different ways. Okay, but at the end of the day, the information that we have is the same. Okay, so that's extremely important. The key point here is that this is a data structure that we use in order to describe relationship between objects. Okay, and the object, well, that depends on your particular problem. And the connections, the vertices, are going to represent the relationship between these two objects. And that particular relationship, well, there are multiple types of relationship. It could be friendship, it could be that I'm liking photos of another one, or it could be that we are, for example, in the same module, in the same class. Well, you can think about so many different relationships. And that's the kind of things that we want to represent with a graph database. It's not the only thing, but there are different situations that we can represent in a graph database. Okay, we can have different types of graph. For example, we can have graph undirected graph, which is that in the connections we are not going to indicate the direction of the node. Okay, basically we know, for example, here we say that there is not a specific direction. Okay, we say that there is a connection between D and C, but we don't say the direction because this is an undirected graph, so no directions. And all we have to do is to indicate one of the two. Okay, we can say that this connection is from D to C, and we can also say from C to D. We don't need both because there is no direction. Okay, we know that these two are connected, and only one of those is going to be enough. We can infer the other one with the data that we have. And we are also going to say that the degree is going to be the number of nodes that are connected to this particular node. Okay, for example, in this case, there is only one connection for this one. So the degree of D is going to be 1. The degree of A is going to be 2 because we have 2 connections. The degree of B is going to be 2 because we have 2 connections. And the degree of C is going to be 3 because we have 3 connections. Okay, so key points here. Undirected graph, we are not going to have the direction, okay, and only one of the 2 pairs is going to be enough, and the degree is just indicating the number of connections that we have in a particular node. And of course we can also have a directed graph, and in this case we are going to indicate the direction. Here the direction is important. Okay, we are going to be saying, for example, in Facebook, you can have, well, not in Facebook, probably no, but in some situations you can have that you are connected with another person, but the other person is not connected with you. Okay, so that's another situation. Okay, and in this case, we need to indicate both connections. Okay, we need, for example, here, we need to indicate that we have this connection A to B, but we also, because this indicates, this connection here indicates that it goes from A to B, but we also need to indicate the other one indicating B to A. Okay, in the previous case only one is enough because we don't have the direction, but here the connection is going to be important in order to represent the starting point and the ending point, the source and the destination. and that's going to be important. Sometimes we can represent, for example, if we have the two connections, we can just put one single arrow with one single line with the two pointing the two arrows. Okay, this is just another representation. And okay, so this is some important things. Now, if we have a directed graph, we can say that we can have the in degree, which is the number of links, connections that are coming to my node. For example, here this is this connection from C to is going to D. So the in degree of D is going to be 1 because we have one connection that is going inside my node. In this case, for example, for B, we have two connections that are going to be 1 and 2. So the in degree of this one is going to be 2. The in degree of A is going to be 1. The out degree are the connections that are going outside, that are going, the source is the particular node. For example, here in C, we have the out degree is going to be 2 because we have two links that are going outside, 1 and 2. This one is 1 and this one is 1. Okay, the in degree. And the degree is just you add the in degree, the degree of the node in a directed graph is going to be you add the two numbers. Okay, this is just a few important general concepts about graph that we have to take into account. Okay, so I already talked about this, so I'm not going to solve this problem again. We can have also loops for the node, so sometimes we have connections from the node to itself. Okay, so this is a self edge. Okay, sometimes we can have this, sometimes we don't use it, or sometimes we use it when this is in as a loop to itself is appearing. Sometimes we don't represent that, but this is just general information depending on your particular situation. In this particular module, if we have a connection to itself, probably most of the time we are going to indicate a connection. Okay, so and of course you're going to represent this as the pair is A going to 8. Okay, so this is just how we are going to represent this in this particular example. Okay, we can have also a few other things. We can also compute. I'm not really going into all these details. We can also compute the number based on the number of vertices that we can have. We can estimate the number. We can indicate the maximum, the minimum number of connections that we can have in the graph. The maximum number of connections, the minimum number of connections, and so on and so forth. And a particular node can have no degree. Okay, that's no degree, no in degree, or that depends. That really depends on the structure or of your particular graph. And that's okay, so that's problem dependent depending on your particular situation. You are going to have more, you are going to have less. So this is just general information, okay? And in particular, in a graph database, we are going to be, so basically this is just general information about a graph, because we need to get some basic understanding of the graph before using that in the context of a graph database, okay? In a graph databases, basically what we are going to store, and we are going to be working with graph, okay? So basically the information, we are going to represent the information in a graph, and then we are going to be populating the graph, indicating which are the nodes, which are the connections, the directions of the connections, and when we want to query, we want to get all that information. For example, we want to get all the friends of this particular person, all the friends of Alex that live in Cork. So basically we have to analyze all those things, okay? And that's what basically what we have to look, okay? We can also include an index and so on, but I'm not really going into this particular details here, as all we want to do is to check the concept of graph databases. Something important about these graph databases, and one of the key things that they use in order to show the functionality of graph databases is what they call the whiteboard friendly, okay? That basically the representation that we have, how we represent the graph databases is how the actual graph is going to look how the actual data is going to look inside the graph. Okay, for example, this is what we represent when we are modeling a situation. Okay, for example, the flights. Okay, imagine that you are in you have to regulate all the flights inside Europe or in the US or wherever. So basically we are going to say that the flight is going to be starting the origin of the flight. For example, here is San Francisco, and then it goes to New York, JFK. Okay, so this is how we are going to represent that when we start modeling that in the whiteboard, designing the graph, okay? And actually this is how this is one possible way of how the actual database is going to look like, okay? Because that's going to be the structure, okay? At the end of the day, we're going to have that the flight is going to be, the origin is going to be, let's say, a city, and the destination is also going to be another city, okay? So basically here the relationship, in this particular case, this is the starting point of the, it's going to represent the starting point of the flight, and this is going to be the destination of the flight. And we can have other things, okay? So that's, and basically, again, as I said, this is how the graph is going to look like, okay? So, and that's exactly what we're going to be studying, and that's how we're going to be interacting with the graph. The situation when we have relational databases is that we start with something like this, the design of this, and then we need to translate this, if we want to work with relational databases, into tables. Okay, so we need to represent a flight. For the flight, we are going to have an ID, and then a number, and then the destination, and so on and so forth. And then we need to create foreign keys, because we need to normalize the database, and so on and so forth. Okay, so there is a significant amount of work after we design the database. We need to represent that inside the relational database. And we are going to be, and that's one of the benefits. Basically, the graph database is going to look more or less in the same structure that we initially defined that. And that's one of the key components of these graph databases.